Namaste. Welcome to the Indian Knowledge Systems primer course for children. In this session, let us look at the area of polygons. In the Vedic geometry session, we saw the origin of Indian geometry in the Vedic era in the texts of Shulba Sutras. In later times, the Indian mathematicians called it as Kshetra Ganita. Let us understand the term Kshetra Ganita. In fact, the phrase Kshetra Ganita occurs as early as 550 CE in the works of Siddhasena Gani. The term Kshetra has two meanings. It can denote planar figure. It can also denote the planar area. We know that Ganita means mathematics. In the mathematical works of Indian mathematicians such as Brahmagupta, Sridhara and Bhaskara too, the section devoted to the treatment of planar figures is called Kshetra Vyavahara. In this session, we shall know the formulae for the areas of polygons that were given in beautiful verses in Leelavati. Before that, we will see a bit about Leelavati and its author Bhaskaracharya. Leelavati was one of the most popular books in all Gurukulas of India for many hundreds of years. Copies of Leelavati manuscripts have been discovered all across the country and has also been translated in numerous Indian and foreign languages. The mathematical work of Leelavati is actually made of 272 poetic verses. They are a mix of sutra verses that give the principles and the udaharana verses that pose problems, puzzles and present applied examples. Bhaskaracharya was not only a great astronomer and mathematician but also a versatile poet, nature lover, profound philosopher and an expert teacher. This is evident from the highly enjoyable verses in this text. Now, let us look at some of the works of Bhaskaracharya. Leelavati. It is a primer text in the arithmetic with numerous examples covering foundational concepts in mathematics. Siddhanta Shiromani is an astronomical work. Bija Ganita is the earliest known text that deals exclusively with algebra. Vasana Bhashya is an auto-commentary, that is, it is written by Bhaskaracharya himself to elaborate more on his work. Karana Kutuhala is a handbook on astronomical computations to assist calendar makers and others. For this lecture, our interest lies in Leelavati. The word Leelavati has two meanings. It can mean the name of a girl. Some legends say that Leelavati was the name of Bhaskaracharya's daughter, to whom he asked various math questions and puzzles. But there is not much evidence for this. Bhaskaracharya asks questions to a girl named Leelavati. He also poses puzzles addressed to the girls and boys throughout the book. Those children, like us, must have enjoyed learning the smart, fast and playful techniques in Leelavati. In Sanskrit, Leelavati means that which possesses playfulness. This work of Bhaskaracharya certainly teaches math very playfully. This is the Mangalacharanam or the invocatory verse for Lord Ganesha given by Bhaskaracharya in his book Leelavati. You can try to chant this verse. It goes like this. Leela galalulallola kalavyala vilasine Ganeshaya namo neela kamala malakantaye. In this invocation, we can understand the imagination of Bhaskaracharya. As this illustration shows, Bhagavan Ganesha is sitting on his father's lap and playing with the black snake coiled around Mahadeva Shiva's neck. This verse we learnt is the 9th verse in Leelavati. This is an invocation before Bhaskara begins his teachings of various methods. The meaning of the verse is Ganeshaya Namaha, which means salutations to Ganesha. How does he look like? He has Neela Kamalamala Kanti, which means he is as attractive as a blue lotus. And it is Amala, that is spotless. It's very pure. What is he doing? He is playing with the Kala Vyala, that is the black snake. And the snake is swaying, that is Lulat. Lulat is the motion of sideways. Lolat is front and back. This verse gives us a sample of the rich imagination and rich poetry in the work of Bhaskaracharya. This is almost like a tongue twister. All verses in Leelavati are very enjoyable like this. Now, let us look at a verse where Bhaskaracharya brings the polygonal inequality principle. What is a polygon? In geometry, a bounded region where 3 or more line segments form a closed space is called a polygon. We know well that shapes such as triangle, quadrilateral, pentagon, hexagon are all polygons. This verse from Leelavati states, for any polygon, the length of any side must be smaller than the sum of the lengths of all its other sides. The verse goes like this. Dhishtodishtam rijubhujam kshetram yatraika bahutasvalpa taditara bhujayutirathava tulyagneyam tadakshetram. What is he saying in this verse? Gneyam akshetram. Know something to be an impossible figure. That is an impossible polygon. Which is that? Drishtodishta. One that is stated by a presumptuous person. That is, one who does not know but acts as if he knows. What is he saying? He is saying that there is a polygon figure where ekabahutaha, that is, compared to one side, itara bhujayuti, sum of all other sides is less or equal. Swalpa means less and tulya means equal. Such a figure is impossible, he says. That is akshetram. Let us consider a polygon with n sides. Let the length of each of the sides be a1, a2 and so on until an. The rule that we learn states that a1 plus a2 plus a3 till an minus 1 cannot be less than or equal to an. That is, the sum of all the other sides must be greater than any given side. See, take a polygon and take any side. If you sum total all the other sides, the sum will always be greater. The Indian mathematician Ganesha Daivagnya has written Buddhi Vilasini, that is in 1545 CE, a detailed commentary on Leelavati. While explaining Bhaskaracharya's verse, Ganesha Daivagnya states that the impossibility can be easily demonstrated using sticks. This will become very clear with an example. Let us now try to construct a triangle with sides 5, 2, 2. First, let us draw a line segment PQ whose length is equal to 5 units. Now, with P as center, draw a circle with 2 units as the radius. Now, PR becomes the second side of our triangle. Then, Q as center, draw a circle with 2 units as the radius. Now, we see that no point in this circle that intersects with previous circle to complete the triangle. Hence, 2, 2, 5 cannot form a triangle. Why? We say that 2 plus 2 is equal to 4, which is less than 5. No side can be longer than some of the other sides. Hence, this cannot form a polygon. The term tribhuja refers to a three-sided polygon, that is a triangle. The earliest known commentary of Aryabhatiya is called Aryabhatiya Bhashya, and it was written by Bhaskara I in 629 CE. In that work, Bhaskara I also defines 3 types of triangles as shown here. Ashra or bhuja means side. Triashra or tribhuja means triangle. This is Samatriashra, which means 3 sides of the triangle are equal. Hence, it is equilateral triangle. The next is Dvisamatriashra, which means 2 sides of the triangle are equal. Hence, it is isosceles triangle. Then, Vishamatriashra, which means all the 3 sides of the triangle are not equal. It's called scalene triangle. Remember, this Bhaskara I is different from the 12th century Bhaskaracharya who wrote Leelavati. Hence, this is Bhaskara I and the one who wrote Leelavati is Bhaskara II. Bhaskara II or Bhaskaracharya in his Leelavati presents the area of a triangle in half a verse. Lambagunam bhumyardham spashtam tribhuje phalam bhavati. What does he say? Phalam means area. Spashtam phalam means exact area. Where? Tribhuje, in a triangle. What is the area in a triangle? Lamba gunam. Lamba means the height. Gunam is multiplication. Height is multiplied with bhumyardham. Bhumi means the base. Ardham means half. So, half of the base. This gives us the area of the triangle. Here, Ganesha Daivagnya says, mark the half of the height of this triangle. That is here. Now, draw a line parallel to the base of the triangle. Next, the word rhombus here does not give us any clue regarding its property. But then see in Sanskrit how beautifully it is explained. Bhaskaracharya says it is a tulya chaturbhuja, that is the one which has 4 equal sides with atulya karna, that means the one whose diagonals are not equal. And what is the area, that is sphutam phalam? What is the exact area of a rhombus? It is atulya karnabhi hatihi, that is the product of the diagonals dvibhakta, and it is divided by 2. In the first half of the verse, the area of a rhombus is given. In the second half, we see he says about tulya chaturbhuja, that is a polygon with 4 equal sides, and it has samashrutau, that is the diagonals are also equal, which means it is a square. For that and for a ayata, that is a rectangle. What will be the area of the square and the rectangle? It is the bhuja koti ghataha, that is the product of its bhuja and koti. Bhuja is the horizontal side and koti is the vertical side. So, these 3 formulae are given in a single verse. Ganesha Daivagnya, in his commentary of Leelavati titled Buddhi Vilasini, has given a geometric reasoning for the area formula of rhombus. Now, let us take this rhombus. It has two unequal diagonals D1 and D2. We see that here there are 4 triangles. Ganesha Daivagnya asks us to duplicate this triangle and put it here. The same way we do it for all the sides. Now, we have got a rectangle. Now, we know that the area of this rhombus is half of the rectangle. Why? Because we have just doubled the rhombus to get this rectangle. Now, look at this rectangle. One side is D1, the other side is D2. So, we know that the area of the rectangle is D1 into D2. Whereas, we know that the area of the rhombus is going to be half of the area of this rectangle. So, the area of the rhombus will be half into product of the diagonals. Here, Bhaskaracharya gives us the area of a trapezium in half a verse. Let us look at the verse. Chaturbhujenyatra samanalambe lambe nanignam kumukhaikhya khandam. There is another quadrilateral, that is Anyatra Chaturbhuje, which is where there is Samana Lamba, that is same height, that is two sides are parallel. Such a figure is an isosceles trapezium. What is its area? Lambena Nighnam, that is height multiplied by. Ku means base. Mukha means face. Aikyam means addition. Khandam is divided by 2. So, the formula he gives is height into face plus base by 2. Now, let us take this trapezium where this is the base and this is the face and this is the height. Now, take these two triangle components. Let this be x1 and this be x2. Now, find its midpoint and cut it along it like this. Now, take this here and take this part here. Now, we get a rectangle. We know that this side of the rectangle is the height. But what about this side? The sum of this side and this side put together is the sum of the face and the base, because only that we have rearranged to put this rectangle. Since these two sides are equal, one side is f plus b by 2, then the other side is f plus b by 2. Hence, the area of this rectangle will become height into f plus b by 2. Now, take a chart and try these demonstrations of Ganesha Daivagnya at your home on your own. Thank you. Dhanyavadaha.